Hello Math 45, this is your instructor Cindy Enrique, and I'm going to continue with chapter 5 and we will start on page 7. So remember, again, this is section 5.1. So here we go with word problems. So this word problem, it states, a farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section at the backyard fence as the 4th side. What's really nice about this word problem is that we actually have a diagram to help us understand what's going on in this situation. So let's see what it's asking us to do. So for part A, find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. So you're just like, okay, so it's asking me to find a formula for the area. Okay, so we know that the part A, for part A, it's asking me to find a formula for area. So whenever I have a regular rectangle, I know that the area is going to be equal to length times width. Except for this particular problem, it's slightly different. It specifically says that I need to find the area of the fence if the sides of the fencing perpendicular to the existing fence have length L. So let's think about that for a minute. So if the sides of the fencing perpendicular, well, hopefully you know what perpendicular means. Perpendicular means that it meets at a right angle, okay? So perpendicular, so they are touching. And we know that they're already using the existing backyard fence as the 4th side. So this is an existing fence. So perpendicular to that has length L. Perpendicular to that is length L. So that tells us then we have a width over there. So we have 2 L's, 2 lengths, and 1 W, which is 1 width, okay? And in case you were wondering, that fencing, well, fencing really has to do with perimeter. Okay. So I'm definitely thinking about perimeter. So here, remember that perimeter means that you add all the sides. And for this particular problem, we only have 2 L's and 1 W, and that's okay. And it also tells us that we have 80 total feet of fencing. So, okay, so we have our perimeter, and it's equal to all the sides added together. So I have 2 L's and 1 W. I also know that my perimeter is actually equal to 80. And to write 1 W is the same to just write it as W. So what we might do here is to isolate one of the variables. So let's isolate W. So that way I have an equation. So I am going to subtract 2L from both sides. So I'm going to have 80 minus 2L is equal to W. And remember that W is actually my width. So for my area, remember that I have length times width. So what I'm going to do here is I'm going to plug in that value for W. So plug in equation for W. So let's see what I have. I have area is equal to length times, okay, here's the width part. This is where I'm plugging in. So I'm going to plug in 80 minus 2L. Okay. And now I'm going to solve for my area. So I'm going to have area is equal to 80L minus 2L squared. And I'm just going to rewrite this so it's in descending order. So a negative 2L squared plus 80L. Okay. So now what I have is I have a formula for area. So there's my general formula because I had 2 L's and 1 W. So that's what I ended up with. Okay, so now let's read for part B. Part B says, what dimensions should she make her garden to maximize the enclosed area? So we have dimensions and to maximize the enclosed area. So for dimensions, So dimensions, that's going to be my length and my width. Okay, that's what dimensions is all about here. Okay, the other thing that we have is we have maximize. Well, when I see the word maximize, I am thinking about the vertex. Okay, so I'm going to find the vertex, and the vertex is going to help me to figure out the length and the width of this rectangular garden. Okay, so let's put that into play. So now we have part B. We are maximizing and we are finding the vertex. So to find the x coordinate of the vertex, hopefully you have that formula, negative b over 2a. So in this case, we have that a is equal to negative 2. That's that number. And b is equal to 80 because that's the number. Okay, so I have negative b all over 2 times a. So the values that I'm plugging in here is 80 for b, and for a, it's going to be negative 2. So when I plug that in and figure out my calculator, it actually comes out to a positive 20. So now I know that for my vertex, I have 20. Okay. Now I need to figure out the y-coordinate of the vertex. Remember, that's when I just plug it into my equation. So the y-coordinate of the vertex, plug what you just found, which is 20, into my original equation. So I have that area was equal to negative 2L squared plus 80L. So area is equal to negative 2L squared plus 80L. So what I'm plugging in there is 20. And so when I plug 20 in, I'm going to get a certain value. When I plug it into my calculator, I'm going to get 800. 800. So let's think about the input of this formula. Notice how my input here is that variable L. So that means that's the x coordinate of the vertex. So my output is my area. So that 800 represents my area. Okay. So I know that to maximize the area, it would be 800 square feet. I know that the length would have to be 20 feet. So now I have to figure out the width. But remember, the width, I had figured that out from before, and it was this formula up here. So width formula was 80 minus 2L is equal to my width. So then 80 minus 2, and that length value that I have was 20, and this is equal to my W. So my width in this case is going to be 40. So now I have all the pieces of information. So now I know for sure that my length is 20 feet. I know that my width is 40 feet. And I also know that my area was 800 square feet, or better yet, feet squared. So those are the dimensions that I was asking for that would make the garden have a maximized enclosed area. Okay. Well, I hope that makes sense. And that is all of the work that we have for this problem. All right, let's jump now to page number 8. So for page number 8, here's another word problem. It says a ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height above ground can be modeled by the equation. So for part A, when does the ball reach maximum height? So, okay, that key word here is maximum. When I see maximum, I should be thinking about the vertex. So, okay, so for part A, my equation that I have is h of t is equal to my negative 16t squared plus 80t plus 40. And I want to find the vertex. So I know that my A is a negative 16, B is equal to 80, and C is equal to 40. So I also know that the x coordinate of the vertex is going to be the formula negative b over 2a. So negative my b value 2 times my a value. So in this case, my b value was 80 and my a value is a negative 16. So when I plug that into my calculator, I'm actually going to get a decimal, and a decimal is fine. So I'm going to have 2.5. Now, to get the y-coordinate of the vertex, that means I'm going to plug that into my equation. So, okay. So, y-coordinate of the vertex. So I have a negative 16. And I have an 80 and plus 40. So what I'm plugging in here is a 2.5. So to get the y-coordinate of the vertex, I plug that into my calculator, and that's what I'm going to get. So I'm going to get this as 140. So my vertex, I have it as a 2.5, comma, 140. So remember, you want to think about your input and your output of this equation. So it says the ball's height above ground can be modeled by this equation. So the fact that it says the height above ground, that's h. So that's my height. Okay. And it says it's feet per second. So t is going to be representing my seconds. So this is my input, and that height is my output. So the input is here for t seconds, and my output is my h, which is my height. So for part A, when it's asking me when does the ball reach maximum height, then I can specifically say maximum height is reached at 2.5 seconds. And for part B, it says, what is the maximum height of the ball? Well, we already did that in part A. We already know the maximum height. So here, the maximum height of ball is 140 feet. That was the y coordinate of the vertex. So I kind of did my work for part A and part B all in part A because it was all about the vertex, okay? So now here's something slightly different. It says, when does the ball hit the ground? So, okay, if I'm thinking about the ball on the ground, so here's the ground, oops. So this is the ground, and I have my ball, right? So there's my ball. What's the height of that ball? So if the ball is on the ground, what's the height? Hopefully you can see that your height would be equal to 0, okay? That's the key thing there. When the ball is on the ground, my height is 0, so h is equal to 0. So, okay. So for part C, height is equal to 0 because it was on the ground. Okay. And so I have my equation still. I still have it. It was h of t is equal to my negative 16t squared plus 80t plus, I think it was 40. Yep, plus 40. Now, with my height being 0, that's what I'm plugging in here, 0, okay? And I still have the same equation, negative 16t squared plus 80t plus 40. So now I have to solve for this. So, okay, solve. I can try to factor. If it factors, I can do the quadratic formula. I can also do the completing the square. So there's either 3 different ways that you can solve for a quadratic, for a degree 2 polynomial. I think for this particular example, I think the quadratic formula is going to be the nicest one. So here I know that A is equal to a negative 16, B is equal to 80, and C is equal to 40. And that equation, if you remember correctly, is negative B plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to plug that into my equation. So I have a negative parentheses plus or minus the square root of B squared minus 4 times A times C all over 2 times my A value. So those values that I'm plugging in, I'm going to plug in a 80 for my B. For A, I have a negative 16 that I am plugging in, and my C value is 40. So I'm going to have 2 different answers here. I'm going to have the positive, and I'm going to have the negative. So I'm just plugging this into my calculator, and I'm going to round to, let's say, 2 decimal places. So round to 2 decimal places. So when I round to the 2 decimal places, I'm going to get a negative 0.46, and I'm also going to get a 5.45. So let's think about this. What I have for my input is time. So this is representing my seconds, because that is the time, my t variable that I have. So can I ever have negative time? No. So can't have negative time. it's not possible to go back in time. So time can only be positive. So since time can only be positive, then we have 5.45 as our seconds. So okay, so height at ground level would be at 5.45 seconds. So if I throw that ball up in the air, it will take about 4.45 seconds for it to be on the ground. Okay. Well, I hope that helps to understand this problem. It's a very nice word problem. So we had maximum height, and when does the ball hit the ground? So there it is, a bird's eye view. So let's go on to page 9 now. So for page 9, we're going to be talking about intercepts. So recall that we find the y-intercept of a quadratic by evaluation of the function at an input of 0. We can find the x-intercept at locations where the output is 0. Notice that the number of x-intercepts can vary depending upon the location of the graph. So for the first graph, we can see that this parabola does not hit the x-axis, therefore it's no x-intercept. This parabola hits the x-axis once, so we have one x-intercept. And this parabola actually hits the x-intercepts twice, or the x-axis twice, so I have two x-intercepts. So you can have none, 1, or 2, depending on the graph. So let's actually put this into play given equations. So it says find the x and y intercepts for the following functions. And you're just like, okay, well, maybe what I'll do first is just kind of split up my page. So that way I can be organized in my work. So the first thing I want to do is I'm going to find my I'm going to find my y-intercept. So y-intercept, and that is when you let your x equal to 0. So you have 3, or let's try that again. So for my equation, I have y is equal to 3x squared plus 5x minus 2. So I'm going to let x equal to 0. So y is equal to 3 plus 5 minus 2. So what I'm plugging in for x is 0. So I get that y is equal to a negative 2. So now I can surely say that my y-intercept is 0, negative 2. I had no problem with that. Now for the second part, I want to find my y-intercept, my x-intercepts. So I'm finding my x-intercepts. That means I'm going to let my y equal to 0. So, okay, so now I have 0 is equal to my 3x squared plus 5x minus 2. So remember, in order to solve for this, there's a couple of things you can do. You can factor. You can use the quadratic formula. Or you can use the completing the square. Those are the 3 different methods that you can solve for a degree 2 polynomial. I think for myself, I think I'm going to do the factor. I can see that this is going to factor. So, and everybody kind of factors their own different way. For me, I like to do guess and check. Other people like to do the AC method. So let's just say I was going to do the AC method. So if I were to do the AC method, I have A is equal to 3, B is equal to 5, and C was equal to a -2. So I have A times C up on top and B at the bottom. So A times C gives me a -6. My B value is 5. So I'm going to have this as a +6 and a -1. So I'm going to rewrite my equation as 3x squared plus 6x minus 5x minus 2. So if I split it in half, well then the first two terms, they have a 3x in common, so I'm left with x plus 2. Over on this side, it looks like I have a negative in common. Okay, and we are continuing with this problem. I just noticed that I made a small error, so I do apologize. That I have 6 plus -5 does not equal to +5. This should have been a 1, so I do apologize. So this one should have been a -1. Doesn't mean I have to do the whole problem over again. It just means I need to rewrite this as a 1. So I have this as a -1x. That's what happens when you go too fast. So notice how -6 times -1 is -6, and +6 plus a -1 gives me +5, okay? So I want to make sure that those two middle numbers add up to a 5 and multiply to a -6. Okay, so now that I have this right, so the first half was still fine, and then the second two, when I do my GCF, it looks like it's just a -1 that they have in common, so I'm left with an x plus 2. So I'm left with 3x minus 1, and x plus 2 is equal to my 0. So I'm going to have x is equal to a 1/3, and x is equal to a -2. So for the x-intercepts, remember I have to rewrite them as ordered pairs, so it's 1/3, comma 0, and -2, comma 0. So those are going to be my x-intercepts. So you have to make sure that you write them as ordered pairs. Okay, well, I'm going to go on to part B now. So for part B, I'm going to try to do the same thing. So I'm going to find the y-intercept. So that means I'm going to let x equal to 0. So I'm going to have y is equal to 2 plus 4 minus 4. And what I'm plugging in here is 0. So I get that y is equal to -4. So I know that my y-intercept is actually going to be 0, -4. So there's my first answer. Now I want to find my x-intercept. So I'm going to let my y equal to 0. And again, I can see my three choices here. I could factor, I can use the quadratic formula, or I can do the completing the square. And in this case, factoring doesn't help us. I just know this isn't going to factor, so I'm going to go with the quadratic formula. So I have that y is equal to 2x squared plus 4x minus 4. And this does not factor. Okay. I know that because I've been factoring for, I don't know, the last 10 years. You can try it and you'll figure it out, but I just want to save you some time. This isn't going to factor. So using the quadratic formula, I know that equation is going to be my negative b plus or minus b squared minus 4ac all over my 2a. And so for the values that I'm plugging in here, well, maybe it'd be helpful if I plug in what are my actual A, B, and C values. So I have that A is equal to 2, B is equal to 4, and C is equal to a negative 4. So my B value is 4. My A value is 2. And my C value is a negative 4. So I'm going to plug this into my calculator and get this to reduce a little bit. So I have a negative 4 plus or minus. On the inside, let's see, 4 squared minus 4 times 2 times a negative 4. That gives me a positive 48 on the inside. And I have a positive 4 on the bottom. So when I simplify this a little bit, I see that I have negative 4 over 4 plus or minus the square root of 48 over 4. That fraction, because it has addition and subtraction up there, then that means I actually have two equations. So this is actually negative 1 plus or minus. Now if I reduce that square root of 48 over 4, and you can do that on your calculator, it actually is going to reduce to the square root of 3. So now I know my x-intercepts. I know it's negative 1 plus the square root of 3, and my y value is 0. And I also have negative 1 minus the square root of 3, and my y value is 0. So that is going to be my y-intercept, or sorry, my x-intercept, since the y value is 0, and I figured out the x value for the x-intercept. Okay? And the way that I found that was by using the quadratic formula, because that problem did not factor very nicely. And as you can see, if I tried to factor, I would have never guessed that square root 3 to be one of the factors. Factoring is only really nice when you have whole numbers to work with, like we did in that first example. Okay. Well, that is going to be the end of section 5.1.